Hello everyone, my name is Shellamae Camance, and today I'm going to discuss about the parabola. Parabola is a set of all points in a plane equidistant from a fixed point and a fixed line in that plane. The fixed point is called the focus of the parabola. So assuming that here is our focus. So the focus is on 2 and 0. And the fixed line is called the directrix. So, assuming that our directrix is a negative 2. So, negative 2 is our directrix. And the line? No, go. And the line through the focus and perpendicular to the directrix is called the axis of the parabola. So since our focus and directrix is on the x-axis, so our axis of the parabola is on the x-axis. And the point where the parabola crosses its vertex. So assuming that our center is at the origin, so our vertex is 0, 0. So this is where our parabola crosses. And the chord drawn through the focus and perpendicular to the axis of the parabola is called the latus rectum. So here is our latus rectum. And the value of our vertex is 0, 0 because our vertex is at the origin. And then our focus is 0 and 8. So the value of our A is 2. So our focus is 0 and 2. And then next is the directrix. The directrix is y equals negative 8. So here is our directrix. Y equals, the value of our A is 2. So y equals negative 2. And then next is the latus rectum. So the length of our latus rectum is 4a. So 4a. So the length of our latus rectum is 4a. So let's substitute with the value of a. So our a is 2. So 4 times 2 is also 8. And then 4 and 4. The length of our latus rectum is 4 and 4. And now, let's find the endpoints of latus rectum. So, let's graph first. So, our vertex is at the origin. So, it is our vertex. Then, our focus is negative 2. And then, our focus is 0 and 2. So, here is our focus. Then, our directrix is on y equals negative 2. So, here is our directrix. And then, let's find the endpoints of latus rectum. So, to find the endpoints of latus rectum, just count 4 from the focus because the length of our latus rectum is by 4. So just count 1, 2, 3, 4. So this is our endpoint. And then to the right naman. And then for the right, just count by 4. 1, 2, 3, 4. So this is our endpoint. So the endpoints of our latus rectum is 4 and 2, then negative 4 and 2. And that is all my. And now let's form our parabola. So here is our parabola. So our parabola is opening upward. Okay, and here is our problem number 2. Parabola of the form x plus 4 to the power of 2 equals negative 4, open and close parentheses, y minus 2, have a vertex at hk, and it opens downward. So let's find the value of our hk. The value of our h is negative 4 here. Then the value of our k is negative 2. So our vertex is negative 4 and 2. And then now, let's find our focus. Post that down. So our vertex is negative 4 and 2. And now let's find the value of our a. So the formula is negative 4a equals y. So negative 4a equals, the value of our y is negative 4. So let's divide. So negative 4 divided by negative 4 is positive 1. So the value of our a is positive 1. And then, now let's find our focus. The value of our focus is negative 4 and 1. And then our directrix is y equals positive a. So y equals, the value of our a is 1. So y equals a. And now let's graph to find the endpoints of our latus rectum. So our vertex here is negative 4 and 2. So here is our vertex. And our focus is negative 4 and 1. So here is our focus. And then our directrix is y equals 1. So here is our directrix. So to look at our endpoints of latus rectum, count 2 from the left and 2 from the right. So here it goes. So our focus here is negative 4 and 1. So from here, we'll just count 4 to the left and 4 to the right. So 1, 2. So let's just count 4 to the right. 2 either. 1, 2. So here is our endpoints. Negative 2 and 1. And to the other side, 1, 2. So here, negative 6 and 1. So, and now, we will form our parabola. So, our parabola, it opens downward.